Number 10, let's write a piecewise function that makes y equal x squared plus x minus 6 over x minus 2 continuous at x equals 2. So this is not continuous at x equals 2. If you plug in 2, you find that you get 0 over 0. So there's a hole in the graph here. So you can picture this graph that everywhere except x equals 2, this graph is a happy graph. But at x equals 2, there's a hole. So it's not continuous. How can we solve that? We can solve it by finding what this graph would be if there weren't a hole. And we can just say, let's have x, f of 2 equal that value. So what do I mean by that? Well, first of all, let's kind of go back to this piecewise function idea, because that's what they're asking for. We can start with writing a piecewise function. Let's call it f of x equals, and let's look at where we're okay. Basically, to the left of 2, our function is fine. It's continuous. There's nothing to the left of 2 that would make the denominator equal 0. So we're okay there. So why don't we just use this function? X squared plus x minus 6 over x minus 2. And what interval is that? That's the interval of negative infinity is less than x is less than 2, but not equal to 2. Okay, again, I wrote that negative infinity is less than x is less than 2, but not equal to 2. That's where our problem is. Now, if you look to the right of 2, it's also continuous. There's no number that you could put in here that would cause problems in this function, except for 2. Everything else is fine. So let's use this function again. X squared plus x minus 6 over x minus 2. And the interval for that would be 2 is less than x is less than infinity. So now all we have to find is what value we want that to be that would make this continuous. So we need a very special value for x equals 2. How can we find that? What does the function intend to do as it approaches 2? Oh, a function's intention is the limit. Do you remember that? So we want to know what the function intends to do as it approaches 2. Well, that is exactly the same, which is why this question is awesome, as saying what is the limit as x approaches 2 of x squared plus x minus 6 over x minus 2. Remember, a limit is what the function intends to do. Well, we already plugged and chugged and got 0 over 0. So that means we know there has to be some way to get a value here. And it turns out that that way is by factoring. I'm going to rewrite my limit notation because I'm still using some x's. I'm going to factor my numerator and get x plus 3, x minus 2. A big hint here. Again, you got 0 over 0. You know something's going to work, probably factoring, and something's going to have to cancel. So x minus 2 is a pretty good guess for the factoring. It's a good starting place. Get x minus 2 down here, of course. And then you can cancel these. And that would get you the limit as x approaches 2 of x plus 3. And notice I kept my limit notation because I still have an x. And now I can plug and chug, and that equals 5. So how can we put that into our function, into our piecewise function? Well, what this is saying is the limit as x goes towards 2 is 5. That's what this hole is. It's 5 in there. This is y equals 5 right here. So if we say right here, 5. So here's how our function works. If you're negative infinity up to 2, use this function. If you're at x equals 2, please just say that f of x equals 5. Here we go. And if you're bigger than 2 and going on to infinity, please use that function. So there we go. Let's look at number 11 now. It'll feel nice to be back to one that's more straightforward. Number 11 gives you kind of dome-shaped graph. And oops, it has an open circle right here, which is at x equals -2. And it wants the limit as x approaches -2 of this function g of x. It's not labeled, but I think you can assume that this function is g of x. And what is that limit? Well, where does the function intend to go? If you're driving down the function street, let's look over here on the y-axis. Yeah, it's 1. So if you were driving from this side, you didn't know the bridge was out, you would think you were going to y equals 1. So that's your answer. Okay, remember, even when it's not continuous, there can be a limit.